Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the problem arithmetic slices. Its index is 413 and it is the medium problem of the LeetCode, and it is also the third problem of the March challenge. Okay, so before moving on, let me talk about the concepts that is being required to solve this problem efficiently. You need to know how the concept of subarray, and that is what is actually the subarray and how to deal with counting the subarrays given the certain conditions. You need to know that you have a good hands-on practice on such type of problems. Also, you need to know the concepts of dynamic programming, not too high, not too low. Like it should be a basics of dynamic programming, how to deal with subarrays involving that. Okay, so let's move on to understand this problem, and we will together build up the best solution for this one, right? Okay, so an integer array is called arithmetic if it consists of at least three elements. Okay, so this should be important, at least three elements. Like if it should have at least three elements or greater than, then we can say, yeah, this subarray or this array is a arithmetic array. Yeah, and if the difference between any two consecutive elements is the same, then only. Like suppose you have a array of this type. Let's say you have an array of let's say a, b, c, d containing four elements, right? Then you can say that this array is a arithmetic array only and only when the length of the array n, which is of this n, is greater than or equal to 3, which is 4, greater than or equal to 3, yes, it is valid, and the consecutive elements difference is same. So it is basically b minus a must be equal to c minus b must be equal to d minus c. This is the criteria. If it is satisfying, then we can say, yeah, this is going to be an arithmetic array. Okay, so for example, you can see 13579. If you calculate the difference, 3 minus 1, which is 2, 5 minus 3, which is also 2, 7 minus 5, which is also 2, 9 minus 7, which is also 2. Every consecutive element difference is a constant. Okay, so we can say that this array is going to be arithmetic array. Also, its length is greater than or equal to 3. Similarly, this one and this one, you can check it out. Given an integer array nums, return the number of arithmetic subarrays of nums. Okay, so this is quite interesting because you have been given some array and you need to find out all the arithmetic subarrays lying in this array, like all the arithmetic subarrays. So how do we keep finding out that efficiently? So there is some special trick, not calling it as trick because it may seems to be quite hard for some of you guys. So there are certain ways to do such type of problems. So I will tell you while explaining it with some examples. So for now, let's look out the constraints, how it is going to help. You can see the max length of this array is 5000. So it gives us the idea that, yeah, we can have a O of n square solution because the constraints are quite low. Like if it is around 5000 or 1000, you can still work with O of n square type solution, right? And also, yeah, this problem can be solved in O of n square time, but also we can have a O of n time solution. I will discuss all that. If you look out my submissions, you can see I have a 0ms solution also. I have also tried to do it with both concepts, like U of n time and U of n square time both. Okay, so if you're done with this problem, I will strictly recommend you to move over to this similar question sections, and you should try this hard problem, arithmetic slices, second part of which is a subsequence. Here we are dealing with the subarrays, right? And so the next concept is to deal with the subsequence. How do we deal with that? How to find all those subsequences count? Okay, so also this, if you are stuck upon this problem like arithmetic slices second subsequence, like it may happen you are not getting some ideas, then you can see I've already solved this problem and uploaded the video over my channel, if you can see, arithmetic slices second, subsequence, dynamic programming, hash map, and it is 446 of LeetCode, day 10 of some month like in the previous year. So you can check it out also. There is a playlist present over my channel, dynamic programming problems plus solutions. Okay, so without wasting much more time, let's move out to understand this problem in detail. So let me first erase all this. Okay, so let me take an example first to find to understand this one. 213579, right? So what we are going to do is like let's claim that dp of I is going to be total number of subarrays ending at index I. Okay, now you guys must have been thinking why I've jumped over directly to the dynamic programming, because you need to calculate the number of subarrays, and the current number of subarrays, like at the current index, ending at the current index, totally depends upon the data or the values that we have previously computed for the left index. Its indexes present to the left of the current index, right? So this is the main idea. So if we are done with this one, yeah, dp of I, total number of subarrays ending at the index I. So what we call this as wait a minute, where is my cursor? I can't see. Yeah, so yeah, so if we are at this position, let me tell you one by one. So you can see there is only one length subarray right now. So I will say dp of dp of 0, if I am considering 0 best indexes, will be 0. It means that total number of subarrays ending at this current position is 0. And let's talk about at this position, like ending at this position. So initially there is only one length subarray. So this is not possible. We need to consider only at least of 3 length subarray. So we will try to extend it. Still it is 2 length subarray. So you can see total number of subarrays ending at this index 1 will be 0. Now let's talk about ending at this index. Note that ending at this index basically means this value is going to be the last value of the subarray being chosen right now. Okay, so if you are at this position, you will be including only one length subarray, but you need to include subarrays of length at least 3. Now it is 2 length subarray, but when you extend it to 3 length subarray, now comes the concept of arithmetic arrays. Arithmetic arrays. Now the concept of arithmetic arrays is quite simple. So if it is at least 3 length subarray, so you will jump to the middle value. Let's say you are at this index I, so you will write down, if you will check it out, nums of I minus 1 minus nums of I minus 2 must be exactly equal to nums of I minus nums of I minus 1. If it is matching, that is actually basically the difference between this one 5 and 3 and difference between 3 and 1. If it is same, which is 2, then you will say yes. It suggests you that yes, you can have sub arrays ending at this index I been incremented by 1, that is the count. So one of the sub arrays is this one. Okay, so you will write down dp of 2 will be what? 1. So this is actually the main idea if you are working at this second position. Okay, now let's talk about this position. Again, you will first decrement it up to this position. Now you will check it out, the difference you can see 7 minus 5 and 5 minus 3, which is again same. So you will just increment it the count by 1, but also your subarrays can be of greater length, like more than 3. So if you find that this subarray 357 is an arithmetic array, yes, it is good, you will increment your count by 1, that is dp of this position, dp of 3 plus equal to 1, because 357 is an arithmetic subarray ending at this 7. You will then extend this to a next position, and again you will check about this position. You will check about whether 5 minus 3 is exactly equal to 3 minus 1. If it is good, again you will increment dp of 3 by 1. Why you are doing that? You can see if d is this difference and d is again the difference between this one, and previously we have already computed at 357 is the arithmetic subarray, so this 35 has the same difference as this one. You can see every element up to this position 13579 1357 has the same difference, which is d, consecutive elements difference. That's why we have incremented by again by 1, which is total number of subarrays ending at the 7, and this is exactly the whole subarray. So what is the count up to this position? dp of 3. So you will say, yeah, dp of 3 will be exactly 2, which is ending up to this and ending up to this. Okay, now let's talk about at this position. Okay, so at this position you can see still you can extend this to, you can see if you consider at least 3 lengths of array, the difference are same, 7 minus 5, 9 minus 7, and still you can decrement your last pointer still at this position, that is this subarray is also valid and this subarray is also valid. It means that in total you have how many subarrays ending at this one, ending at this one, and ending at this one. It means 3 subarrays. So dp of 4 will be what? 3. dp is basically counting down. Okay, so here we are not basically using the dynamic programming, right? So but this will have the complexity of this type of approach is O of n square, and we have space as O of n. Okay, in the next approach I will discuss how we are going to use the previously computed values to find out the subarrays ending at the current position. So first of all, let's check it out the solution. Okay, so of O of n square time and O of n square, O of n space, you can see time complexity is O of n squared, space complexity is O of n. So I will write down dp of I as number of arithmetic subarrays ending at the index I. So I will start with 2 because we have to consider at least 3 length subarray, and j as I minus 1. So we will run this loop. So write down while j positive, and you can see if you are finding out the difference of 3 elements at the jth index, if it is same, increment dp of I number of counts of subarrays ending at this index I and decrement g. Okay, if you are done with this entire for loop, you can see we need to report all the subarrays ending at every index. So we will just find out the sum, which will be our answer. So this has the complexity as O of n square and space as O of n. But we can do better. We can have O of n time and O of n space solution, which I will discuss right now. You can see O of n time and O of n space. Now the concept and the idea is very much simple, and it is like so let me just okay, so let's keep this value. Okay, so suppose what we are going to do is we are just finding out the value at this position, right? And we have the values at this position as 0, 0, 1, 2. Okay, so it means that the total number of subarrays ending at this position is 2. Okay, so now we need to find total number of subarrays ending at this position. So what we are going to do is we are going to check the difference, the values of consecutive elements just before the current index, which is 9 minus 7 and 7 minus 5. And if it is same, you can see these are the values same, d and d, which is 2. So what I will do is like dp of I exactly equal to 1 plus dp of I minus 1. This is actually the relation. Means total number of subarrays ending at this current position will be incremented by 1 with respect to the previous value, that is the previous value plus 1, when the difference between the consecutive element just ending at this current element is again same. We can extend this subarray, right? So if you're not getting it, let us take another example. Okay, suppose we have the elements like 2, 5, 8, and let's say we have the values as 10, 12, and let's say 14. Okay, so this is the value. So what I am going to do is like first of all I will check it out, the value at this position, total number of subarrays ending at this one is 0, and again this one is 0. So when we are at this position, we will try to find out the difference of consecutive elements, this one, right? So which is again 3. So dp of I exactly equal to 1 plus dp of I minus 1, which is 0 plus 1, which is 1, right? But when we are calculating this value, you can see 10. Let's try to find out the difference, which is 3 and which is 2, which are not same. So we will leave it as it is, so which is again 0. Again we are finding out the difference between this one and this one, which is again 2, and again what is this value? 8 to 10 is again 2, and 10 to 12 is again 2. So we will write down 1 plus the previous value, which is 1, and again you will try to find out this value and this value. 10 12 is 2, 12 14 is difference is 2. So we will 1 plus 2, 1 plus 1 is again 2. So which is actually this one. You can see total number of arithmetic subarrays ending at this position 14 is actually what? 10 12 14 and 8 10 12 14. This is actually representing the count. You can extend that subarray if the difference is same. So again you can see if the value 1 is coming because you will have this subarray, value 0 is coming because you cannot have 3 length subarray, value 8 is coming because we have this length subarray. So this is the idea basically. So let's look at the code. Here it is almost similar. So we have dp of n plus 1 size, dp of I number of arithmetic subarrays ending at index I. If the 3 elements difference is same, extend the subarray, that is previous length plus 1, which will be the count. So nums of I minus nums of I minus 1 will be equal to nums of I minus 1 minus nums of I minus 2. So dp of I will be 1 plus dp of I minus 1. Right, and finally we need to return the total number of subarrays, which is the sum at every index, which will be our answer. So which will give you a runtime of 0 ms and quite faster solution. Okay, so if you guys have still any doubts, you can reach out to us through the comment section of the video. And thank you for watching this video, and do not forget to like this video, share this video, and subscribe to our channel.